Hi everyone, today our group Crystal, Jolin, Marvella and Aurel will be talking about hybridization. Carbon has 6 electrons, so its electronic configuration is 1s2, 2s2 and 2p2. However, in its excited state, the electrons have to prepare for bonding, so its electronic configuration becomes 1s2, 2s1 and 2p3, because the electron from 2s2 moves to 2p and so it becomes half filled. So there are 3 types of hybridization: sp, sp2, and sp3. What determines if it's sp, sp2, or sp3 is the number of bonds.
An example of sp3 hybridization would be methane. Now methane has 1 carbon atom and it is bonded to 4 hydrogen atom. Now carbon has 1 s orbital and then 3 p orbital. And they will actually form hybridization. And then it will look like something like this, which is the sp orbital. But make sure you don't get it wrong. There will be 4 separate sets of sp orbital. So each one of p orbital will be bounded to s orbital. So in total there will be 4 separate sets of sp orbital. This sp orbital will look like this. And then we put this 4 sp orbital into the diagram. However, hydrogen has only 1 electron. And they have s orbital which is shaped like a sphere. So this will be bonded, and when this type of bonding form, they are actually called sigma bond. So there are 4 sigma bond.
In Ethane's case, it has an sp2 hybridization. This is because each carbon atom has a total of 3 bonds. 2 sigma bonds are formed with the hydrogen atoms, and 1 sigma bond is formed with the other carbon atom. Only 3 of the 4 electrons of the carbon is used for bonding. So only 3 orbitals are hybridized, while the remaining 1 orbital, which is the p orbital, will remain as it is. The 3 hybridized orbitals will look like this. Same goes for the other carbon atom. It will form a bond with 2 hydrogen atoms and 1 carbon atom. Therefore, this carbon atom also has 3 bonds in total, which means that there is 1 remaining p orbital that is not hybridized. The 4th electron from each carbon atom will occupy a p orbital which overlaps sideways with another p orbital on the other carbon atom, forming a pi bond. Due to this, a carbon-carbon double bond is formed.
Let's not forget to add the 2 sigma bonds formed by each carbon and hydrogen bond.
So let's talk about ethine. Ethine is basically C2H2, which consists of 2 carbon atoms and 2 hydrogen atoms. Now this would actually be the electron configuration of carbon atoms. However, this is only the 2s and 2p, so let's keep that in mind. Now, the 2s orbital would have a spherical shape. Keep in mind that these are in their excited state and not their ground state. Now, since 2s has a spherical orbital and 2p, they're all single field, there would be 3 separate dumbbell-shaped orbital. Now, for the C, it will actually be bonded to a single hydrogen atom and another carbon atom. Now, these would only be 2, but keep in mind that these would actually have triple bond. So, when these are only 2, it will actually form a hybridization between a single 2s orbital and a single 2p orbital, which forms sp orbital, which is shaped like a fish. But it will form not only 1, but 2 separate orbitals. Now, this is what it will actually look like. Now, the same thing will essentially happen for the other carbon as well. So, this will actually overlap. And this would be the overlapping. However, we know that hydrogen also has 1 electron, so it would actually be spherical shaped. Now they will also overlap. Now this type of overlapping will actually form a sigma bond. So far we have 3 separate overlappings, meaning 3 sigma bonds. However, we can see that there are two other dumbbell-shaped orbitals not being used for a single carbon atom, and they will actually overlap as well. Now, this, they have two, right? And this also have two. So they will actually overlap as well, kind of like this. So they overlap at two different areas. And this overlapping is not called a sigma bond, but it's actually called as a pi bond. So in total, there would be 3 sigma bonds and 2 pi bonds.
And that is it from us. Thank you for listening.